Okay, so what we're going to talk about in this video is the subject of exact differential equations. So what I'm going to do in this video is to take the time to go a little bit more in depth with respect to uh, exact differential equations, as opposed to my last video where I spoke about simply how to solve a differential equation using the exact method. So we know that often the solution of differential equations are implicit solutions, where we have a function f of x comma y of x is equal to some constant c, which defines y of x as an implicit solution to the differential equation. So the thing is that from this identity, if we derive with respect to x on both sides of the equation, we find that let me actually use the partial derivative notation here. So we find that df dx plus df dy times dy dx is equal to 0. Right? What we've done is we've implemented the chain rule here. If we derive this equation with respect to x on both sides, then we find df dx plus df dy dx is equal to 0. Now, if you look here, right, we can write df dx and df dy as simply m and n, where m is a function of x and y, and n is also another function of x and y. So what we can say is we have m of x comma y plus n of x comma y times dy dx is equal to 0. Okay, so this is typically the, well, not always, but it's typically the form in which an exact differential equation is written. You'd also see it written in this form, where you have m of x comma y times dx plus n of x comma y times dy is equal to 0. Okay, so this form is referred to as the differential form. Okay, so this is the differential form of the equation. So we notice a few things here, right? The first thing we notice is that df dx, put 1 here, df dx is equal to m of xy. We also notice that df dy is equal to n of xy. Now, in the special case where n of xy is equal to -1 and m of xy is just some function of x and y, then this equation here actually becomes f of xy minus dy dx is equal to 0, which means we have dy dx is equal to f of xy. And this is nothing more than your typical general first order differential equation, right, in x. Right, so if y is a differentiable function of x, then what we have here in the case where n of xy is equal to -1 and m of xy is just some function of x and y, then we have a first order differential equation here where dy dx is equal to f of xy.